Hello and welcome. It's Lab Talk. I forget which number. I think it's 26 because we've been doing so many of them lately. It's our wrap-up show here. It is 26, I'm told. It's our wrap-up show here on the 14th of November, Electronica 2024. We still have one more day of this. And I'm joined here by Stuart Cording.
Hi, great to be back on the show.
And of course, we have DIY guy Chris, whom I don't have to hand a mic because you're wearing a headset.
Well, yeah, it's nice to be here with you guys. It's I really appreciate that you bring all the makers here and consider it a special edition, and I'm so happy. Yeah,
great. And I'm trusting you all had a good time. Let me start with you. What was the most interesting thing you've seen this week so far?
Excuse me?
The most interesting thing you've seen this weekend,
This week, actually, I'm so happy that I met the YouTubers, Gray Scott and Max. That's the first thing, like, special, because I'm all the time seeing people from behind the screen and never get, like, a direct contact with YouTubers and makers. And I've seen, like, cool stuff, like the robots and many things around Red Pitaya gadgets, and I think that it will be a potential collaboration with Elektor. Then maybe I can get more stuff on like content about them, and many other things like meeting my sponsors directly here, because both of my sponsors are already in Electronica, and I was so happy to see and some friends from those sponsors, and we've had some cool time.
Yeah, and it has been exciting. I mean, I met you. I've had you on the show before remotely. I've met Great Scott. Max Imagination is just sitting down, joining the audience. We've had Peter Dalmaris, who's also done live webinar with us before. Natasha Baker from SnapMagic's is here. So we've got a whole plethora of people, but most excitingly, I get to see Stuart Cording again. How was your week?
Very kind. It's been absolutely incredible. I've been coming here. This is my 20th year, I think, of attending Electronica. So my very first Electronica, I was working at National Semiconductor. It was the first ever trade fair I ever attended, and I was so excited, absolutely blown away at the opportunity to represent the company. We just launched Bluetooth. That was the new thing back then, and we had a demonstration for a Bluetooth system for a car so that you could build in an aftermarket system. And one of the ladies that came along to look at it, she used it to call call her daughter in the US. So I have no idea what that telephone call cost at that time. But that was my first experience on the show. And what really pleases me about being here this week is just the fact that it's so well visited, that we've got so many representatives here. I come a lot more from the industry and from the business side, and everyone's talking about a bit of weakness in the market and budgets being cut, and we're losing jobs here and there. But there's no sign of that here. When I first came to Germany back in the early 2000s, this site only had, I think, 12 halls. And then the Hall C row, which is 6 extra halls, has been added in the meantime. So now Electronica has 18 halls. This is the first time I've ever seen all 18 full. We have 192,000 square kilometers of space. Square meters, or 192,000 square meters of space. According to DigiKey, there's a truck out the front. It's 26 kilometers to walk all the way through the halls.
Yeah.
And over 70,000 visitors from 100 different countries. Yeah, and so it's just a potpourri of engineering and interaction and meeting people, as you were saying as well. Meeting people sometimes, like you say, you've never met in person before, which is fantastic. But for me, the big thing here is the amount of innovation that's been going on. Electronica only happens every 2 years. And I've been confronted with applications which have been stretching from kilo amps down to nano amps and even pico amps. There's a really interesting new startup called Nano Power, who I spoke to the other day. They work in this sub-threshold technology area. This means that the transistors are only being switched by half a volt instead of having the threshold a lot higher, like you expect with a microcontroller, typically a 3.3 volt microcontroller. That means they save loads of energy. And their chip is designed to be used in IoT sensors. So, you know, they can treble or increase the lifetime battery maybe by 10 times with their technology. It's a brand new chip. They've done their second tape out and fixed the bugs in the first one, they were telling me. And that looks really, really interesting. The other thing I learned was a new acronym. We love acronyms in our industry. I'm very used to ADC, the analog to digital converter. Well, now I can introduce the TDC, the time to digital converter. That was completely new to me. But Sensor I was talking to, they're an environmental sensor company. They've actually developed this little chip which measures down to picosecond, 20 picosecond accuracy for laser pulses, and it's going to be it's targeting laser-based application, laser ranging application. Uses an innovative ring oscillator technology to get that accuracy. And the amazing thing is, this is a tiny device, 150 milliwatts of energy. It just uses standard oscillator, standard quartz, so nothing very expensive, so it keeps it very low cost. And when you look at what it replaces, which is typically an FPGA implementation with a lot of energy consumption and a lot of complexity, or even a very complicated analog circuitry, that's the other way they typically do those applications. You can see how people here, they look at a very fine part of an application like LiDAR and say, that could be made so much better. And then they go and do it. And then they show it off here. Absolutely amazing.
Yeah, I mean, my first computer was 3 megahertz, so the clock cycles are 333 nanoseconds apart, and now you're talking about 20 picoseconds. That's more than way more than 1,000 times the accuracy, being able to measure a signal like that. Yeah. And yeah, as you say, this place is huge. So if you want to walk efficiently and you don't want to go around booths and that sort of thing, there is an expressway upstairs that goes almost from the west entrance to almost to the east entrance. And I've counted the steps because I've got the watch, and it came to about 700 meters from one end to the other. So if you go back, it's almost 1.5 kilometers. So there's no wonder we do no fewer than, say, 15,000 steps here a day.
Great workout. Yeah.
And I need it, yeah. But there's no way you'll see everything. So you've got to have your highlights. Is there anything you haven't seen that you want to see?
Well, definitely. There's little things that pop up all over the place. I want to go back to Electronica and see what's going on over there, because we've been talking about influencers and content creators. We had Great Scott we were talking to earlier as well. And I keep an eye on how these companies are sort of reaching out to new audiences and informing youngsters as well about the fact that they have electronic products, what electronics is. This is the most amazing industry in the world. We were talking with some friends recently and sort of comparing it back to the gold rush. So they said, like, do you know who made money during the gold rush? It wasn't the people trying to mine the gold. The people that made the money during the gold rush were the people selling spades. Yeah. And I think, it's time that everybody woke up and realized that we are the silicon spade. Yeah. So it's silicon that is making AI. It's silicon that's making generative AI, ChatGPT, and Midjourney, and all these things happen. And it's silicon that's making sensors that can live anywhere and run on a battery for 20 years. So silicon's a place to be. Electronics around it's a place to be. The software, the architectures, and supporting infrastructure around it all. And this is really, the source and the home of all that to bring it all together.
Absolutely. It's where it starts. Most people don't look under the hood often, but I'm going to check in with the chat here. Frank DeHat, he's back. Frank.
Hi, Frank.
You're always joining us. So loyal. I just wonder if you have too much time in your hands.
And Annie's there as well.
Yeah, Annie T. So Annie T says hi. And I'll go over to you, Chris, to ask you what highlight you're looking for.
Actually, I would love to see if Espresso are here. People of ESP chip are here, because I searched it on maybe I searched the wrong way on an interactive map. I didn't find them because I want to see them like face to face. And I saw the ship in do the management of the power, the management, the nano
power.
Yeah, exactly. And I really appreciate that they're providing also a dedicated software that displays in real time the signals, and when the ship get intervented to wake up the modules, to wake up the sensors, and from like the sensors up to the microcontroller, etc. And I asked them that golden question that I asked you this morning, but you didn't have the answer: the price, because it's it's important to produce something very interesting, but getting in a higher price, then it's useless because nobody will buy it, even if it's important. But I think these guys will that chip around $2 on 1.8, I think. So I believe it's accessible compared to its use. It's good.
Yeah.
And maybe something also, I share the point of view of Max. I've been wondering why there's 3D printing exhibitors, 3D printers, manufacturers, exhibitors here. Maybe I searched it the wrong way also, but I want to take a look around for them. And yeah, that's it.
Now, I was also just referring back to the question we had here from D. Conti. So what's the big topic in Munich this year? AI, power? And I think the answer is yes, it's AI and it's
AI,
power. One of the companies I was talking to is a test and measurement company that I follow very closely called Liquid Instruments. Now they have, we know there's this trend away from a big grey box on the desk to just having a box with BNC connectors, and then I connect it to my PC. Or I connect it to an iPad. They have an iPad-based system with an amazing analog front end, and it's not an oscilloscope. It's a configurable laboratory instrument, so you can stitch in software all these little pieces together, and you can create. You can do power measurement. You can do phase analysis. You can do things in optical lock things. I can't remember the name of. But the one of the things they've been showing here this week, which is really fascinating, is they can actually then bind. There's obviously lots of filtering and mathematics, just like on a normal oscilloscope and a frequency analyzer and that. But you can now bind in your own neural network into part of that as well. So, and what they were showing me was a neural network that they trained, and this neural network is capable of filtering out noise on analog signals, for example. But instead of the classical way you do it is with FFTs and everything, you'd have some sort of DSP type functionality to do that, but then you get a phase shift in the output. By using a neural network, it actually keeps the phase delay really, really small. So that was quite interesting. Now on the power side, as I said before, we were just talking about nano power. So on the one side, we've got lots of companies focusing on very low power for IoT, for battery applications. But then you're also seeing, lots of innovation in GaN, in SiC. You've got people like Infineon with electric cars. We've got Mauser with the fastest Beetle, I think, in the West, which is a Tesla-based design. But again, it's all about efficiently converting power from DC to AC, AC to DC for wind turbines, renewable energy, photovoltaic, motor inverters in the EVs, charging the batteries, onboard chargers, and all of these things. So we're seeing lots of innovation in the area of SiC and GaN. Recently, Infineon, for example, have just announced that they're now manufacturing GaN on a very large wafer. Why is that important? Well, that means each GaN die that you cut out of that is going to be cheaper than ever before. And GaN's made huge headway into mobile phones, smartphone chargers. I show my age, mobile phones. And so seeing that there and talking to TI this morning as well, they've just brought out a new C2000 real-time microcontroller that's got a very, very high performance brand new core, which does eight instructions per cycle. But the important thing about that is that processor performance is then coupled with very high precision PWMs integrated with the ADCs. Why is that important? Well, that means I can do very tight, high-speed control loops to make my DC-DC converter, to make my motor inverter. So, power is a topic from lots and lots of different angles.
Yeah, and you just mentioned 8 instructions per cycle.
Yeah, exactly.
So no longer are we measuring cycles per instruction, but instructions per cycle. And I got a comment here from Max Imagination who says, "Hey, Chris, no, it may be remote, but if you turn the camera around."
You could have just walked over.
If I can ask Mick to turn the camera around, there's Max Imagination. Max. Don't be shy. You can say hi in real life. Then we've got Peter Gilbert from South Wales saying hi. In terms of highlights, I did do an interview with Eben Upton. We sat there, but it wasn't live streamed, so that has yet to be published. That was a lot of fun, and I found out a new side to him. He's also a train geek, so there is an overlap. He went into a 2-minute talk about how trains work. And I said, well, there's definitely an overlap. He said there's a huge overlap. And then he went into another 2 minutes about trains and rounded it up with how Raspberry Pis work. Now, personal highlights of mine. We sat here a couple days ago and we were talking about smart cars, and I mentioned the show Knight Rider from the 80s, which is one of my favorites.
The original smart car.
Exactly. It talks, and what a computer that thinks, and it alerts you on your smartwatch. A little far-fetched, right? Turns out New Power Worldwide brought in David Hasselhoff in the next hall, which was a surprise to me. So if I may show my highlights to the camera, I got a photo with my icon.
I'm very jealous.
I wouldn't smile if I were with me either.
You got to sit with a Hoff.
And I hassled the Hoff.
The best opportunity, I think.
Yeah. He's big in Germany, I hear.
Okay.
He's very big in Germany.
He took that wall down with his own
With
hands.
his own hands. He sung the bricks away.
Yeah. So what I'm looking forward to tomorrow is we've got the startups joining us, the Fast Forward competition. We've seen a lot of their presentations right here on this stage. And it's going to be a tough choice. I think we've got to discuss tonight, right, Eric? Yeah. And tomorrow, award ceremonies and your soldering competition, right?
Yeah.
Tell-
Exactly.
Tell us a bit more about that. What you're going to be challenging people to do.
Actually, the participants have to try to solder the components of the circuit board. By the way, I've heard like some feedback about the design, which is special here. The silk screen, actually, yeah, it exists. There are some PCB manufacturers who could provide you a PCB not blue or green or yellow, but with a customized image in it. So you're moving from the classic way into some unique way, unique style. And actually, the participant has to solder these components going from a coin cell battery holder to a switch, just a classic small circuit. Then it has like 4 LEDs of package 1206, then 4 resistors. And here is the challenging point. The resistors package goes from the 1206 package. Next is 0805, then 0603, then the smallest is 0402.
That's cruel.
Yeah. So the more skills you have, the best you get. And in order to get all these LEDs working perfectly and normally in a good conditions, you have to make no shorts and you have to solder each point. If you make any short and the resistors, the LED will be so much brighter than the other LEDs. If you don't have soldered the point, the LED will not light up. Probably the easiest one is the coin battery holder.
You mean the one I can see without my glasses?
Well, that's why I asked for this part here. And tweezers are critically needed. And well, yeah, it's just for fun. I called it a skill tester. And the smooth of the LED brightness is the sign of a correctly assembled circuit.
And so is this the test that you use before you employ new people at your company?
Probably, yeah.
So give us your top tips then for people who are going to come along and take this challenge. What is it? Flux first, lots of heat. What's your tip for soldering SMT?
Tweezers first. Tweezers is the first critical thing that you need to pick up then. The solder tip is so important because you're dealing with the small parts here. Picking up a thin solder tip will make it difficult. Actually, I tried with different solder tips, but okay, it works. And the solder core section, it has to be thin, and it hasn't be like not so much thickness on the solder core, because if it's so thick, then the moment you just get it molten, it's gonna be like a big drop. And also flux, if you want to make higher contact. But I managed to make this. The surface finish is a golden nickel. It's a nickel surface finish for a higher connectivity, and it attracts the solder flux combined in the solder cores like so fast. Okay, so it's easier for soldering, and well, not easy for the rework, but I've brought some solder wick also if they want to make some rework. And yeah.
Now, this is a really important question. Do you use your solder wick dry, or do you put solder on your solder wick before you use it?
Okay, it depends on the solder wick. Some just are made of only or majorly copper only, but some includes a little bit like a little bit of flux in it. So you don't have to just pull an external thin. When it touches the thin, it just it absorbs the heat quickly from the iron and just spread it to the thin and just absorb it. So it depends on the solder wick, yeah. But sometimes, yeah, I do that. I do add some solder thin when it doesn't work,
Yeah, exactly.
and for no reason,
Yeah.
I just
keep going. Just keep
yeah.
trying. Stab it, stab it, stab it.
Exactly, yeah. You know it when you started making like electronics repair and electronics rework, and that's what I do so often in my professional job. And yeah, that's how it works.
Well, I see. I mentioned Natasha Baker from SnapMagic is here earlier. We've had her on the show before. I don't know if you could give up your seat for Natasha.
With pleasure.
Good to meet you in person. This is the
Yes.
first time we're meeting in person on live stream.
Yes,
So
although we did have that amazing Zoom call recently.
yeah,
so-
that was great.
yeah, great to
And
see
you,
you.
you enjoyed that, and you said you would be here. You kept your word, and I've been past your stand 4 or 5 times, and every time I come past, you're busy talking to someone. So you must be exhausted, first of all, but it must be rewarding.
Yeah, very rewarding, extremely busy, but I mean, nothing beats Electronica. I mean, Electronica, I am such a super fan of the show. It is incredible. It unites people from all over the world, and it makes me feel so like it makes me feel even more passionate about our industry, that it brings people from so many places. I mean, I shared a cab with someone from Tunisia, from the electronics industry, and are you
Tunisia,
also
right,
from
yeah.
Tunisia?
Yeah.
Oh wow, okay. And you know, people from the UK, people from Canada. I saw people from my alma mater from Canada, people from Silicon Valley where I'm from. It's just I love this show.
Yeah.
So happy to be here. How about you?
It's been great, and I've had more time to get around than I believe you have, because you've been stuck there talking. Not stuck there. You're clearly enjoying it, but you can't leave much because you got to represent your company. It's a small company, although a big company in terms of what your impact is. And
Thank you. Yeah.
you're still clearly passionate about it. And I have to say, you don't look tired, which is a good thing. And but you do have a lot of passion for the industry. You said you landed in Silicon Valley and you saw tech ads in the airport, and that
Yes.
was like mind blowing for you.
It was. Yeah. It was absolutely mind blowing when So I'm from Toronto, Canada, and I studied electrical engineering, really wanted to start this company in the electronic space. And I struggled a bit, to be honest, like finding my people, like finding the people that were into EDA back in Toronto and finding my folks. And I was sharing when we were last chatting that when I got off the airplane in Silicon Valley, there was an ad for Cadence. And I was like, oh my gosh, like in the airport, there's an ad for Cadence? Like, this is insane. And of course I've moved there now, and it really is incredible when you find your people and you find like, this is my industry, these are my people. And it's such an amazing feeling, as I'm sure we all feel here. So
Yeah, absolutely. It's a pity this is only a week long, because these are your people, and you'd probably live here if you could.
absolutely. Absolutely. Yep. I wait for this every 2 years.
So what have you achieved? You got a lot of leads, you got a lot of connections, networked a lot this week.
Yeah, so a little bit about SnapMagic. We are building the AI Copilot for circuit board design. Some of you might know us as Snap EDA. That was our former name. We started as a search engine for electronic component CAD models. We're now pairing those CAD models with AI to automate circuit board design. And so we make everything free for electrical engineers, because we really believe that if we can give engineers all these resources, we can empower them to design and innovate for the future. And the way we make money is we partner with the supply chain, so suppliers to distributors. And so I spent the past couple of days just meeting with so many of our partners, and of course, lots of engineers, giving them Copilot demos, getting their feedback. So yeah, just lots. You know the drill. Lots of meetings and things
So you
like
have
that.
fans too who come by and say they love your product, and
Yeah, and we love that. Like, and yeah, of course, that's like, those are the best moments. And of course, we have a lot of our engineers here. some of our mechanical engineers. A lot of engineers are sharing how much they love our 3D models. We have our mechanical engineering manager there. So it's just so nice to close that loop and also get feedback. I mean, there's areas where engineers have features that they want or things they want us to add into the app. So getting that information back to us is super helpful too.
Awesome. So almost one more day to go. And I say almost one because I know at the end of the afternoon, people start packing up. What are you hoping to achieve in the last few hours tomorrow?
Oh, that's a good question. So we have lots more meetings tomorrow too. So yeah, I don't know, just kind of continuing to connect with partners and engineers and probably more of the same. I don't think there's anything too groundbreaking tomorrow other than that. But
okay.
Yeah.
And you're going straight home after the show, or are you going to see a bit of?
I'm going to tour around a little bit. I don't quite know where I'm going. Every year after Electronica, I tour a little bit of Europe. Last year I went to Austria. I went to Vienna and Salzburg, which were super beautiful. My first time there. So I don't know where I'm going to go this year. TBD. I'm kind of winging it a little bit, but yeah, maybe I've been thinking of maybe heading over to Copenhagen. I haven't been there before, so just kind of touring a little bit of Europe. It's my excuse whenever I come here. So
living the life, aren't you?
Just for a couple of days. That's all I have. But
okay, well, thank you very much, Natasha Baker
so
from
nice
SnapMagic.
To see you again, Brian. Thank you.
We'll chat soon.
Thank you so much.
Thanks, Stuart. Welcome back.
Back in the hot seat.
Yeah.
No, I think that's fantastic. One of the questions here was what's the role of AI and this sort of thing. And I think there's a lot of hype around AI at the minute. And one of the companies I was talking to earlier was saying everyone's a bit tired of AI in this industry. It's like everyone's talking about AI all the time. And I think maybe on a broader scale, when we look at so much stuff going on with Elon Musk and ChatGPT and generative AI and fake videos and all that sort of stuff, I can understand that frustration and boredom with all of this again.
Yeah.
But I think the most important thing is to understand that in our industry, it's making an absolutely huge difference. So you've got the team that we've just been talking to. They're using AI in a very intelligent way. It's making engineers' life easier when they're trying to design their circuits. And also at the edge, the other thing is it's so critical at the edge in microcontrollers. The fact that our industry has managed to take huge AI models and then shrink them down so we can run them on tiny low power microcontrollers. I mean, we were talking like microwatts of energy consumption. So I was talking to TI. We did an interview with them this morning. And one of the challenges we have in the renewable energy sector is that these large solar farms, especially sitting on roofs and things, they've got these long strings of solar cells. And over time, you can get a bit of corrosion on the connections, or you can have insulation breakdown. And what can happen is that you can get arcing around different parts of the circuit. And when the arcing gets too bad, it can actually set light to the whole thing. So there's been examples. I think there was the one in Arizona where a roof almost burnt down due to this arcing problem. So what TI have done is they've actually developed a very tiny algorithm which helps them to detect arcing. Now, arcing's typically detected using FFTs in a DSP type application, but the problem is it's very difficult to bin the noise because the noise of arcing moves depending on the capacitance of the solar cell against the roof, the weather, the humidity. There's all sorts of things that influence it, and it's noise that moves around, and it's broadband noise. It's not a very clear signal. But with AI, because the AI is really good in these very complicated sort of multi-dimensional or very noisy signals, it's really great at pulling those things out. And then you can put it into a microcontroller, and all of a sudden, you know, they've gone from a 60% detection accuracy with an FFT on a DSP and really pushed it up to sort of 90-95%. And I think, you know, AI just it's like a surgeon's tool almost. You can stick it in and actually position it very well in little places to solve little problems that would have been very difficult to try and program in a switch statement or an if-else statement. Yeah.
So it's not just lithium-ion batteries we have to worry about. Now it's arcing on circuit trace.
Arcing on your roof.
Oh, okay. Back to you, DIY guy Chris. You had a bit of a luggage delay, so now your toys have arrived. What can you show us here?
Yeah, okay. So here we're having all the things are about LEDs. But well, I'm in love with LEDs, and I like to complicate my life. That's why I always run for small stuff, and I like deal with it. And actually, that's the purpose of what I'm doing, is to showing the people the appropriate way to deal with the small and compact stuff, because nowadays, in order to get several functionalities in one circuit board, you need to pick up the smallest components to suit like the size required for that circuit board. Otherwise, it will end up like with like this one. Well, it's a classic PLC looking, but this is an 8 years old design, and since I released it, it has been working like for 8 years, 24 hours a day, 7 days a week, no stop, for 8 years. And actually, it has been removed from the machine that when I implemented it, because not because the board is bad, it was perfect, but because the machine is an obsolete model, so the company has moved it to a newer version. But what would surprised me, actually, the model that they bought is not the latest one, but it's the next generation. But what surprised me is the functionalities that we designed it for this circuit board has been implemented in the new generation machine. So we did this circuit board to just provide some functionalities that missed on the old version, and the manufacturer probably noticed this, and they implemented it on the machine, and it was like, yeah, it works very well.
You must be very proud.
Yeah. Actually, I'm proud that I designed the circuit board that ran it for 8 years and no stop with no failures. And I took some precaution because I didn't clean it when I get it out of the small like protective box, because I added a small fan to extract the dust. And when I never opened it, because then well, it works.
Never
then,
touch a running system.
Yeah, exactly. It works, then it works. So just keep it. Now, don't.
If it ain't
don't
broke,
be so,
don't fix it.
Yeah, okay. And don't be so curious sometimes. Yeah. Okay. And when I opened it, I was about to cry first because they just took it off. But when I opened it, I was surprised because no dust, nothing. It's been like it has started working today, and I'm so proud of this actually. And this one has a funny story. I've been telling the same story over and over today about the visitors. Actually, I go to the gym. Not so often, by the way. But I'm having a gym partner.
I appreciate your honesty.
Oh, yeah. And my gym partner, hopefully he's watching now. Yeah. He will recognize himself. He's a lazy guy. And he's always cheat on counting sets. So, for example, if you do an exercise and we need like 4 sets, we do 3, and he said, no, we did 4 already. Okay, that's a problem, because we all the time arguing and talking about this. It loses the concentration, and sometimes I give up and go train myself and say, okay, go away. So I find out a way to just build this small circuit board, which is wearable and battery powered. And it has a built-in recharging circuit with a lithium battery. So all what I have to do is wear it and turn it on. Then all what you need to do when you go to, before doing the exercise, you need to set the target, like how many sets you need to do, like 1, 2, 3, 4 sets. After completing, and you forget about counting, after completing any set, you just click this button, and on the other row, it displays how many sets you did. So this is the target, and this is what you did. Okay, so we go 1, 2, 3. And if he said that we did 4 already, okay, here's 3, not 4. One remained. So after that, okay, done. Ready for the next exercise. Then he has no more way to cheat, no more cheating. He gained some muscles because of this, actually.
He doesn't know what a good friend you are.
Oh, yeah.
And of course, he used LEDs.
Yeah, actually, it actually looks like a binary watch, maybe.
That's what
actually,
I thought it was.
the problem is not like a big problem But actually, the problem exists, and it got solved somehow with this. But it's just a proof that with the simple stuff, you don't have to gain some specific knowledge, but by practicing, you make it perfect. And with the simple stuff, you can solve your own day life problems. Okay. So because in the market, you cannot find a dedicated device that do this. And by the way, someone just mimic it, but it was bigger one, and the pushes is by foot, not by hand. Yeah. And I was so happy to see that he shared this on Instagram, and I was so happy because that's what I do, actually influencing people and pushing them forward to follow. This one you already know is the big cube that I posted on Elektor magazine. Actually, this was my first contact reason with Elektor. Since then, everything was like awesome with Elektor, honestly.
So take us a bit through the LED cube. What was the most challenging part of making that project?
Okay, when I decided. Okay.
Just having a bit of fade there from the
great
transmitter.
So when I first decided to make this project, it wasn't like dedicated for something or just because I love LEDs, but it was the release of the microcontroller from Raspberry Pi, the RP2040. It's them first ever microcontroller, and they posted some documentation to show people how to make the hardware setup around this microcontroller in order to make it work properly. But I didn't see like a lot of content, enough content around it. But it's a very cheap microcontroller, and at that moment, people were struggling because of the lack of microcontrollers. It's just the period after the pandemic, so there is this a lack of a shortage of many models, especially the 80 mega 328 by 8ml, and it's my favorite, but it's missing. And I remember that in order to get like 80 pieces of this microcontroller, the price gets like around $24 a piece. It was like $1 before the pandemic. I decided to buy 80 Arduino Nanos because the price is $7, like not a fake ones, but it has the microcontroller. The price is $7. So I just took off that microcontroller. I killed all of these Arduino Nanos, and I took off the microcontroller. It's better than spending $24 for each piece. So actually, in order to push forward people to play with the microcontroller RP2040, I decided to do anything around it just to test the setup, the hardware setup. I tried like 2 or 3 times. It doesn't work, but finally I achieved a successfully working circuit board following the documentation from Raspberry Pi, which is great. And I pushed some PCB manufacturer. I don't know if I'm allowed to say the name of this man. Okay, JLC PCB. I pushed them to get this part and then parts library for PCB assembly. It's not easy to convince someone about your thoughts, but they trusted me and they brought that chip to them library after cooperation with the Raspberry Pi. And then on Twitter, people start doing PCB assembly around that microcontroller, and it was like huge, a huge spread on the social media. And actually, fantastic. I did only one project with the RP2040, which is this LED cube. Yeah.
Now, obviously, we see a very clear trend with your projects here. It's all about the LED. So can I ask you, do you use Charlie plexing, and have you figured out a way to explain it simply?
Okay, that's actually a question from Great Scott only this morning. Charlie plex is a trend nowadays. It's an old school technique, but it has like gained some followers and fans today. Actually,
it's a hot topic on social media.
Yeah, sure. Actually, I remember that the Arduino Uno Out4 LED matrix is a Charlie plex LED matrix. I saw that in a schematic. I noticed that the Charlie plex setup. No, I didn't do this, but I will, because in the future projects, I still don't make it, but I will try to deal with the world's smallest the world's smallest RGB LEDs of a size 0.65 millimeters. So
Good luck.
These ones, yeah, I like complicating my life, as I said. These ones actually are the world's smallest addressable RGB LEDs, with a size of 1 by 1 millimeters.
Wow.
And I soldered this cube myself. So it's like assembling 384 pixels. Yeah, it's nice.
And how long does that take?
Around 4 hours if you have the necessary tools. With a stencil, it's good. It's faster.
Okay.
With a stencil, it's fastest because the tough part is not the pick and place, but the solder paste depositing. But with a stencil, it's like you take it. It goes faster, yeah.
And so you put that in an oven and
not an oven, but on a hot plate.
on a hot plate.
Yeah.
Okay. Now we've had a couple of questions that popped up as we were talking along. So Annie T says, "So cool." She's also asking, "Do you have a favorite project? If you could make one of your projects, it's you're sent to a desert island, and you're allowed to take one project to make with you. Which one would you take?"
I would take this one. The
So
smart
tell us about
robot.
that.
This is the second version. Actually, the mechanical parts are not my design. It's available open source. And this robot used to be made around Arduino Uno. But with the connection and the pins of the Uno, there's so many limitations. So I decided to make my own circuit board. And I added the functionalities that I want. I have some LEDs as always around here, and a buzzer, and a connector for OLED display, and ultrasonic sensor connector, headers, and servo motor connector, etc. But the good thing is that you can get all the manufacturing files from the description of the YouTube video, and just deliver all these files to any PCB manufacturer. It will deliver to you this circuit board as it is now. All what you have to do is plug the USB cable and start programming, for sure, after uploading the Arduino bootloader, but it's not a big deal. But I choose this one because, as I said, I've been a lonely maker for a long time. So this guy is a good company in a desert.
Yeah, exactly. Yeah. So I think we're sort of running out of time. So
yes, we just heard the nice German lady on the intercom announce that the day is done.
So what I just thought we'd just ask Chris, DIY Chris, just tell us where people can find you on social media.
Yeah, mainly, actually, I'm active in many platforms like YouTube, Instagram, Facebook, LinkedIn, Twitter, basically everywhere. But the main focus is on YouTube and Instagram. Instagram is my favorite because the content, it wasn't my favorite. I'm not so fan of the platforms where many videos are push it forward, but that's why I'm not so active on TikTok. But for Instagram, the algorithms are different, and Instagram wasn't my favorite before, but I tried it, and it like grown up so fast, and I gained so many friends out there. So Instagram my favorite, and YouTube is also a good place to just share my projects.
Awesome. And in terms of community, backing each other up, you're up here. Max Imagination is down there. We've got a comment here from Build Your CNC at Max Imagination. Cool stuff on your channel. Just subscribed.
+1.
Max says thank you. So yeah, I think we can wrap it up then. It's been a busy week and a busy day. And this will be our final lab talk from here. Tomorrow is the last day. So thank you very much for joining us. Thank you, Stuart, for coming.
Thanks for inviting me over.
And of course, DIY guy Chris, we will be watching with great interest your soldering competition tomorrow.
Thank you. Sure. Yeah, sure. Yeah.
And thank you to everyone joining us from remotely and in the room. And have a good night, morning, afternoon, wherever you are in the world. Goodbye.